All right, let's look at a solution for the going ham function. So this says Hamming distance is a measure of how different two strings of equal length are. So we're always going to assume that the inputs into our function are going to be two strings of equal length. Hamming distance is calculated by comparing the strings element by element. For any given position where the two strings differ, the Hamming distance value will be increased by 1. This has applications in biology, comp sci, encryption, and many other fields as well. Complete the Hamming distance function below. This function takes two strings as arguments, as described, and returns the count of differences between two strings. So, one thing I want to highlight here, this line, which is now on line 8, for any position where the two strings differ, the Hamming distance value is increased by 1. So this is something to keep in mind as you're reading a problem statement. And when I read this, I instantly think of a for loop. I mean, not just because it starts with for, but that's often a good indicator, happily. But because this is just describing by example, this is basically an example of an accumulator that's just being described here. So we're just increasing something by 1 given a certain condition for every element in a collection. Cool. So let's just write that out. So let's have we got to have our accumulator. I'm just going to call it ham. And we'll start it at 0. And I'm going to say for, let's just do this with a range first. For I in range. And remember, range's input is an integer. And we want to go through the range of the length of one of these. Since these are both the same length, we're going to just assume that they're always going to be the same length. It doesn't matter which one we choose. I'm just going to say len a. And the len function takes an iterable and it returns the length of that iterable as an integer, right? So in these examples here, all the strings are length 3, so because there's 3 elements, 3 characters in it. So len takes in a string, a list, tuple, any iterable, and returns the length. So this will give me, it returns the length as an integer. That's 3, or that's an integer, and then that's the input to range, so we're good to go. Okay. And then all I have to do from here is just use this I to index into the string to get each element and compare it. So I'll say if a sub I, which will be the ith element in A, if a sub I not equal to b sub I, then we'll say ham plus equals 1 and return ham. Oops. Save that and run it. So we look at the output pattern here that I have listed. We should see 0, 1, 2, and 3, and that's what we get. 0, 1, 2, and 3. So let's just submit this and prove that it works. Oops, ignore the prior solution. I'll just delete that. Okay. Cool. Let's look at a slight variation on this, and oops, let me switch back to my editor. All right, let's look at a slight variation on this. Instead of range, I wanted to show this solution first because I think of this as very simple set of tools. I mean, writing a for loop through a range is just a simple, easy thing that we teach early on in basic prep and in our Python materials, our beginner Python materials. So using range and len, these are simple, common functions that, the way they work is pretty intuitive and easy to deal with. But as you can see, they have a pretty they're pretty powerful. You can really do a lot with range and len like this. So just because they're simple doesn't mean that you can't do a lot with them. And this is, this is a pretty simple problem. But one thing that I could do here is, and I would think that this solution, the one I'm going to show, is just slightly preferable, to me at least. We could use zip, and we could zip A and B together, and we're going to get the A character, which I'm just going to call AC, and the B character, which I'm just going to call BC, in zip AB. And then from here, I can just say AC and BC where I want to refer to that character. And this is, I would say, this is a logically identical solution. I didn't change like the structure or the way that I'm thinking about this problem. All I changed here is the particular way in which I'm acquiring each element, right? Before I was using a numeric index to index into the collection directly, and this is just giving me direct access to the element. 6 of one, half a dozen of the other, doesn't really matter. But zip is a nice tool. It makes parallel iteration problems just a lot easier. So let's, again, verify that this will work, prove that this will work in Learn. See, it's running tests, and it says correct. And just for fun, let's just show a comprehension solution for this, because I know some people will want to see a comprehension. I feel like I need to give a disclaimer every time I write a comprehension and say, if you're not at the point yet where comprehensions are making sense, that's okay. If you feel comfortable with just writing regular for loops, that's fine. Don't buy into the hype around like, because you will hear this, you'll encounter this idea that like if you're not writing comprehensions, you don't know Python, or you're not really programming, and that's not a legitimate that's not a legitimate statement, I think. So for loops are fine. If you're producing robust working solutions, then nobody's really got anything on you. But just for fun, let's do a comprehension. And to be clear, nothing against comprehensions. They can make really elegant and good solutions that can occasionally be very well optimized. So they're great, but they're also not strictly necessary. So there's a couple ways we can do this. I'm just going to write the comprehension part first, and we'll see what to do with this. So I'm just using the word comprehension on its own, but it's important to remember when we're doing a comprehension, we're actually basing it out of some collection type, which is either going to be a list, really a list, or a dictionary. And then if we wanted a set or a tuple, we would do a list comprehension and just cast it to a set or a tuple accordingly. So they're really list and dictionary comprehensions, and then you can cast to whatever set or tuple or whatever from a list. So let's write a list comprehension, and we'll see what we end up with, and we'll see how to utilize that. So I'm just going to say, how should we do this? I'm just going to say 1. So we're going to put 1 in the list for A, C, B, C in zip, and we'll use zip again, A and B. If AC not equal BC. So if A is not equal, AC is not equal to BC, we'll just put a 1 in the list every time that's the case. So let's run this and see what our output is. Okay, so notice my expected output was 0, 1, 2, 3. Look at the lengths of my list. Or alternatively, look at the sums of the list, right? The sum of the numbers in the first list is 0. There's nothing in it, so it's 0. The sum of the first one, or the second one, is 1, 2, and 3, right? So I could just do the length or the sum here, right? So this is nice. I've got this list, and I could say sum, since I'm just adding 1 every time. So this is a pretty common way to be able to do a counter accumulator in a comprehension form, is to just add 1 in the list and then sum it, or add, whatever val here, whatever the value is. You can sum it, and in this case we can take the len. Either way, it just doesn't matter at all whether you do len or sum in this case. So let's just submit that, prove that it works. Correct. All right, there you go. And let's just look at the suggested result here, or suggested solution. They did use different parameter names, doesn't matter here, but they're calling this a count, and they're running through range len stir1, which is what I called A. So that was consistent with my original solution. So one other quick note here, we looked at a few different ways of solving this problem, but in any case, whether we're using range or zip or this comprehension, um, I don't consider any of these three approaches to be actually logically different, right? Like in any case, it's always loop through the elements, compare elements across their indices. If they're different, add 1, right? There's a little bit of a juggle with the comprehension solutions, because you end up with a list and then you pass that to len or sum. So but in any case, you're adding or incrementing something under the same condition. So paradigmatically, in terms of the algorithm, these are all the same solution. And I just wanted to mention that this is a kind of a beginner problem, and I wanted to mention that to get you all thinking about, or just to share like how I think about different solutions and how I look at them. A different solution to me would be something that, where the way of thinking about the problem is different in a significant way. Whereas these are just variations of implementations of thinking about the problem in the same way. So, yeah, just thought I'd share that. Cool. Hopefully that was helpful.